very happy today to have Rick Myron himself, and we've been looking forward to having you, Doc, for a long time. So welcome.
Thank you.
I'm gonna read very quick Dr. Rick Myron bio, and he is the number 107 on our webinars now, and we have another 40 online. And we're very happy and we're very excited. We're trying to get you speakers from every single corner of the world, all the diverse information for you at the convenience. Dr. Richard Miner is currently the lead educator and researcher at the CRF Education, and faculty in Bern University. He completed his PhD studies since 2009. He has currently published 200 peer-reviewed articles and lectured international many topics related to materials. For the past 3 years, Dr. Myron has been recognized today as one of the top 100 CE providers in the country and the youngest to ever make the list. Also, the top-ranked researcher in platelet-rich factor therapy as per experts' state independent review. He has recently been awarded many recent international prizes in dentistry and is widely considered as one of the top contributors to dentistry, having won the ITI Henry Roeder Prize and the IADR Young Dentist of the Year in the field of implant dentistry, as well as the IADR Sopransky Research Award in the field of radiology 2020. He has written 5 textbooks, widely distributed in dentistry, including his bestseller in 2019, titled Next Materials for Bone Integrated. Wow, Dr. Rick, welcome. We're very excited to have you.
Thank you. Yeah, thanks for the kind introductions.
It's very impressive. We know you're originally from Canada. And all the way from Canada, you decided to study your PhD in Switzerland, and then you moved to Florida. Very different cultures and very different experiences. What made you move from Canada to Switzerland? What got you interested in going your PhD there?
Yeah, it's actually a interesting story, of course, and it's long ago that this all happened. But essentially, when I was studying dentistry and doing research in dentistry, I was linked with my supervisor at the time, who was Doug Hamilton, and he had received a big grant from Straumann to look at surface topography of implants and coating them with different bioactive biomaterials, so growth factors and other things like BMPs. And the study was funded by ITI, which is the research group by Straumann, and I was getting to know these guys very well, always with the research reports back and forth for a 2-3 year period. And when I had graduated, I applied for a big research award in Canada, which would be a fully funded PhD. So I ended up winning this award, which was great. And so then I had basically a green ticket to go anywhere in the world. Everything was fully funded. Every flight was paid. PhD stipend was paid. Everything was paid. And so then I interviewed across the world, many different schools in the United States and Canada and Switzerland, Italy and France. I went all over the place. And out of all of the schools, of course, I was very highly drawn to Bern, Switzerland, because I was doing implant research at the time. The school that I decided to choose was Bern, and many great colleagues are located there, as well as Straumann is located directly in Switzerland. Nobel Biocare is in Switzerland. Many of the zirconia implant companies are in Switzerland, and so it just seemed like a great hub to go there. And I ended up choosing Bern, and that's how I went there. And then from there, like I said, I spent a number of years doing my PhD research and stayed on for a couple of years after that to be head of preclinical research for Dr. Boozer and Dr. Quillian's team. And after a while, I decided to move back to North America, simply for a couple of reasons. One, I missed my family and my friends, right? So being that far away all the time was difficult. My sister got married, it was starting to have kids, and brother was doing stuff, and I was just missing out on a lot of things. The birth of my sister's first child and all these things. So I just said, it'd be better if I was back in North America. And I chose Florida because half my family actually retired here. So my parents moved to Florida. They retired here half the year. So half the year they come to Florida, the other half they spend in Canada. My brother had moved down to Florida as well. So it just seemed like a fun place to live. Of course, it's very cold in Canada. If you've ever been there, in the winters, it can be minus 20, minus 30 Celsius, and it's just awful in the winters. And I've been blessed to be in Florida since 2006. Yeah, the beaches are not so bad. So, yeah. Although I don't get a lot of time to go to them, but yeah.
You should. How many years did you spend in Switzerland?
I spent 7 years there, on and off. And yeah, like I said, that's where a lot of the big contributions of research from my side of things went, and I owe a lot to my mentors. Without question, Dr. Sculian was one of the reasons why I was drawn there. And strangely enough, I was doing all these research projects on Emdogain back in Canada, and every second paper, about 15 years ago, was written by Tony Sculian. And having the chance to meet him and then work with him for a number of years, and now I've known him for more than 10 years. Has just been a lot of fun to be part of his team and try and grow and do a lot of work with the team there. If you think about it this way here, very logically, when you have these big name guys like the Sculians and also the Daniel Boozers of this world, every company wants to work with these guys, right? If you're a Danny Boozer in the implant field, every single company wants to say, we're working with Dr. Boozer, we're doing this. And so he's obviously extremely busy with all the work that he's doing, running the clinic, the department, his own personal lecturing schedules, etc. That when there was new materials that would come into the department, they would always get basically funneled down to the young people to do research with. And that was me. That was me and UFUM. And so we got to test all these new materials, and no joke, a lot of these materials, we would be the first people in the world to test new implants from, whether it be Straumann or Xeramax or new types of biomaterials. We'd be the first guys in the whole world to be able to use these devices. And so that's basically how we had written the textbook, Next Generation Biomaterials, from all these cool little toys that we were playing with when I was in Bern.
Perfect. Rick, give me a second. Some people are mentioning that there's no sound here, so I just want to make sure that being heard.
Yep.
Okay, give us a few minutes. We're trying to check the audio.
Yep. No problem. Is the audio working now?
I don't think so.
No?
Now we have audio. Perfect. So,
yeah?
Yep.
Okay.
We were just talking about, I was asking Dr. Rick about what got him interested in going to Switzerland, and I know that he's originally from Canada, and Canada all the way to Switzerland, from Switzerland all the way to the United States in Florida. And everyone knows about Dr. Rick Myron and his immense contribution to the research and the PRF and the diverse information and education that he have. And everyone knows his enthusiasm as well, like with all what he's doing. He is the star of our generations in the PRF, for sure. And I was just asking him about what got him interested in going to Switzerland. So if you don't mind just telling the story again.
Yeah, no problem. No problem. Yeah.
Sorry.
Glad that we're live again, so no issues. Yeah, basically, when I was in Canada, this was more than 15 years ago, I was doing research projects that was directly linked to Straumann implant surfaces. And so I was a biologist in the dental school. My supervisor, Douglas Hamilton, was highly funded by the International Team for Implantology. And we were doing all this research with coating implant surfaces with new bioactive molecules. And this was things like Emdogain at the time, BMPs. We were doing work with PRF, this type of growth factors. And after the project was published, I was fortunate to publish in a good journal, Biomaterials. And from there, I won a big scholarship. And it was a Canadian scholarship that gives out 2 to 3 of these scholarships to different students that want to pursue a PhD. And it's fully funded, which means that whoever wins this award gets, up to 5 years of funding, full funding, 100% everything paid for. And so I always say it was like a green ticket for me, where now I can go to any school in the world and I'm fully funded. Every flight's paid for, all tuitions, PhD fees, everything's paid, living expenses, food, everything. And so I interviewed in the United States, I interviewed in Canada, I interviewed in Switzerland, Italy, and France, different places. And out of all the schools that I visited, the school in Bern, Switzerland was most attractive. And the reason why I always say this is that, number one, it's got a very high reputation internationally for the research that they do. But more importantly, I was doing a lot of research in implants. And if you think of the major implant players in the whole world, so if you look at Straumann is located in Switzerland, Nobel Biocare is in Switzerland, all the zirconia implant companies, the Xeramax, the Z Systems are all located in Switzerland. And so for me, it was a nice place to go because you're literally 30 minutes away from every single one of these headquarters. All of the research that they do in Switzerland from the main companies first get tested in a lot of the Swiss universities. And so it was really cool. A lot of these implant surfaces, the first people to ever work with these were actually in our lab. And so it was a way for us to be really at the forefront of that research. And like I mentioned already, when you work with guys like Daniel Boozer and Anton Skulien, which are both well-named big names in implants and in perio, every single company wants to do research with these guys. And because of how busy they are running the departments and their clinics and lecturing and traveling and teaching and everything that they do, a lot of times these new materials would get funneled down to us students, us PhD students, us residents, postdocs, and we'd actually be the first people in the whole world to actually test a lot of these different biomaterials, which was just amazing. So, it was a great experience.
And best Swiss watches too.
Best Swiss watches and Swiss cheese and Swiss chocolate. So a lot of things in Switzerland are high quality.
Yeah, you spent 7 years there.
I did, yeah. I spent a long time there. So it was on and off, like I said, for 7 years. And I was head of preclinical research as well.
Wow. What made you come back to Florida? I was just mentioning.
Yeah. So after I spent 7 years there on and off, of course, I wanted to stay connected with my family and friends. So I was always making these trips that were taxing on the body, going to Switzerland, coming back to Canada, or going to US. And at the time, like I said, I remember thinking my cousin got married, my sister got married, my sister had a child, all these different things. And sometimes I couldn't make weddings or I couldn't make, baby showers, etc. And I felt kind of strange being out there, just dedicating my entire life and soul and everything I had to research, which is honestly, like I said, every day we were working. And just got taxing after a while, and I wanted to be closer to my family. So essentially what I did was a lot of the work that we were doing, which is kind of cool now for me, I think my job right now is a lot better than what it was before, was that we were doing a lot of the first human studies and clearance studies for FDA and CE. And so for European, we were doing a lot of this research. And now I do the same job here in North America, where I take into our labs and into our departments a lot of these new biomaterials. We test them, we do a lot of the research with them, and then we try and get them through the FDA clearance system. And for people that work around the world, they always know that new products come to Europe always before they come to the United States, right? This e-clearance is a little bit faster. And so a lot of times you see Straumann has a new implant system that's available in Europe. And then it takes 2 years before it's accepted here in North America. So one of the focuses that I try and do is try and make that process a little bit faster. So to work with different companies, do a lot of the FDA clearances. We write a lot of these documents with partnering with the FDA to get them through a little bit faster, as fast as we can, and bring these new exciting products to the US market and Canadian market as well. So
we're very excited about all your research that you're doing. Is just amazing. You're the star of the PRF in our generation for sure. So
yeah, we've done a lot. I think, of course, I owe a lot of credit to how I was basically raised in the science world, because when you go to one of these high-end schools like in Bern, Switzerland, they're very critical. I mean, it's very intense. It's not like a normal school by any means, and it raises the level to the point where now I'm just doing normal research based on my standards, but all of a sudden, when I compare this to what everybody else is doing, it's elevated. It's very serious, and I've just learned how to do it a certain way. And so we're always publishing in the top ranking journals. I kid you not, when I was in Dr. Skulien's department and also with Dr. Boozer, a lot of times we were just not allowed to publish in journals that were not in the top ranking, 10% of journals. They would just say, if it's not going to be in the top, then just throw it away. We don't want this stuff. and so you get used to that type of seriousness and almost competitiveness, and all those guys are very competitive. So, you just adapt that philosophy and just keep going. So I've been doing the same basically in Florida, and that's how we keep publishing and keep the level.
And all of us have been seeing it very clearly in all our research, like your research. We're very excited about the lecture that you're going to be giving us today, and we're going to have a lot of longer discussion at the end as well. If you're ready, you can go from there.
Sure, yeah, I'd be more than happy to. Here, let me just make sure that, can you see the screen right now?
Yes, perfect.
Perfect. So, since the lecture is relatively a short period of time, there was a couple things that I wanted to kind of get across, kind of the newest technology that we have in platelet-rich fibrin, and just understanding where the advancements have been made. As you mentioned, our group in Burn is ranked #1 in the world, so it's not just me. It's many people, Yufeng Zhang, Tony Scullion, Misako Kobayashi. A lot of us have really done a lot of research in this space, so it's without question teamwork. And I wanted to just kind of give, the gist of kind of the advancements made in PureF therapy. And then from there, at the very end of this lecture, I'll give a coupon code, which is called GIS, which will go to our online PureF EDU platform, where you can watch literally 6 hours of videos, which will cover all of the new and exciting things that we've done. But this will be more of an overview. So as I mentioned, like I said, I spent many years in Bern, Switzerland. For those that have never been to the school or know anything about the school, it is the highest, most citations per paper are to this university. So every year, like I said, when it comes to citations per paper, so you publish research articles, they get a ranking based on the different universities. Bern University is ranked #1. And a lot of it has to do thanks to these two guys who I owe a great deal of respect to for all the things that they've done for me. But Tony, like I said, is very well known for his work in periodontal regeneration, and Dr. Boozer is very well known for all the things he's done with GBR, implant surfaces, etc. And I spent many years working in preclinical research with these two guys, so Dieter, as well as Reinhard Gruber. For those that know these guys, Reinhard was the head of oral histology when I first went there, so I basically just followed him along and did everything he'd asked of me, but he's a very, very smart colleague, now works in Vienna. And Dieter is one of the top oral histologists in the world, and he's literally pioneered a lot of new developments in implant dentistry. Tony, like I said, is very well known in perio. In fact, this past year, he won one of the top awards in the world by the IADR for some of his contributions to the field. And you'll see his name on a lot of the PureF articles. So Yufeng is one of these guys that a lot of people don't know. He's very well known in China, but not really well known in the rest of the world. And interestingly enough, when I won this scholarship to go from Canada to Switzerland, he won a scholarship to go from China anywhere in the world. And like myself, he wanted to go to one of the top schools, so he went to Bern. And we were the two guys that were testing a lot of these new biomaterials, whether it be PureF, whether it be bone grafts, barrier membranes, etc. And over the course of doing this for literally 10 years, we had lots of knowledge, and we wrote this textbook together called Next Generation Biomaterials for Bone and Periodontal Regeneration. It's very, very well known. Internationally, it was the top ranking book in the world earlier last year. And I always say the reason why is, #1, there's no reference textbook for biomaterials. So how should you use PureF? How to use allografts versus xenografts versus other types of materials? That's a big open question that there's not a lot of data or textbooks on. So that's one of the reasons. And the bigger one, I think, is, most clinicians will get a lot of their knowledge on biomaterials from sales reps. So, a lot of sales reps will say, well, now we have this new type of membrane, or we have this new type of bone graft, etc. And unfortunately, like I said, that's probably one of the last places in the world you want to learn about, newer technologies in dentistry from. And this book basically filled that gap. And of course, in it, we talked a lot about PureF. So, PureF, very simply, it's a long history of work that's been done in this field. We're not inventing anything. I always say that. We owe a lot of respect to guys like Professor Robert Marks, as well as Arun Garg, who many years ago invented the whole field with PRP and how to separate layers. And, I go back to their articles 20 years ago and just reread them literally to figure out, what the differences are, because they have a lot of these pioneering studies that are very effective at concentrating these platelets. And long story short, out of all the blood cells, out of platelets, red blood cells, and white blood cells, platelets is what they found were the guys that really help with regeneration. And so the goal of a centrifuge is that you're separating cells based on their density. Light cells go to the top, heavy cells go to the bottom. Of the group, the red blood cells are the heaviest, they go down. Of the group, the platelets are the lightest, they go to the top, right? So platelets are the light guys, they get shift to the upper layers. Now, the benefit of PRF, so to speak, over PRP is simply the fact that you're removing the anticoagulants. And by doing so, you're going to form a clot. And by having all these cells and growth factors trapped in the clot, then the advantage is you get a slow and gradual release of these growth factors. Now, I always say in my courses, I don't get into debate who the inventor of PRF is. Some people think it's just a trade name. Other people think it's stolen from the PRP guys, and I never get involved in that discussion. What our lab is focused on is, where's the technology today? Can it be improved? And if yes, then we try and just basically help the field. As well, we spend a lot of times trying to get these things through FDA clearances. So as you know, a lot of these PRF technologies are not FDA cleared. Not a single device is FDA cleared for medical use. So believe it or not, you can't use PRF for things like diabetic foot, treatments. You can't use it for knee injections, although people do it. It's not FDA cleared. And so one of the roles that I take upon myself is I try and collaborate with different people in medicine and get these things FDA cleared. That way they can be utilized more widespread. Now, the advantage of PRF is that you're basically concentrating growth factors that help with angiogenesis, so new blood flow, cell recruitment, as well as TGF-beta. I'm not going to get into discussion of each one of these, but long story short, any tissue that you want to regenerate, whether it be knee regeneration, bone regeneration, soft tissue regeneration, hair regeneration, skin regeneration, you can always benefit from having more blood flows to those areas. You can always benefit from having more cell recruitment to those areas, especially when they're stem cells, as well as having these cells proliferate. So it's one of the reasons why, whether it be PRP, PRF, you always see that these are being utilized in many different fields of medicine, as well as dentistry. Okay, so the goal of the centrifuge, of course, is to separate these cells based on their density. And as I mentioned, some of the pioneering studies are dedicated to these three colleagues here. And of course, if you want to improve the healing, one of the things that's been learned more recently is, of course, the anticoagulants. So when you can remove these, and I always say a lot of the ability to remove the anticoagulants has to do with the differences in tube technology. And I'll show some of the stuff that we've been working on more recently. So again, you're going to draw blood, you're going to spin it in a centrifuge, and then you're going to create these different layer separation. For those that want to learn more, like I said, you'll have access to the free online platform where you can learn more about how these cells are separated, etc. Now, there's different protocols that we use, and each of these protocols does something totally different, in fact. So the one that most people know about is the regular membrane. Okay, and the regular membrane, the goal of it is basically just to separate the cells so they're evenly distributed. Others, such as the liquid PRF, are utilized basically for facial aesthetic type things where you want a little amount of volume that's more concentrated. Others, such as the CPRF layer, are taken from the Buffy coat layer, which are much more concentrated in platelets and leukocytes. And again, if you don't know the differences, let's say you're a clinician, you just say, well, I follow this protocol because so-and-so told me to, but you don't understand why you're actually separating using different protocols. I highly recommend, like I said, reading some of our group's research articles, because we've literally taken 24 different protocols from the same patient, and we spin it 24 different ways to see where the cells are going and in which layers they go to when you spin at different protocols. And based on that data, then we give recommendations for, how to spin liquid PRF versus a solid PRF versus concentrated PRF versus whether we do ALB PRF, et cetera, et cetera. And those papers, like I said, are one of the reasons why our group has been, highly ranked, because of all the ability now for clinicians to very easily say, if I do this, I understand that I get this. If I do this, I understand why I get that. One of the problems in the PRF world is, why do we spin for, X speed for this amount of time? And you say, well, because so-and-so told me so. And, scientifically, when you want to be doing these things, you actually want to understand better, what you're doing. So it's one of the things that our group's really done a lot of research in. Now, tubes. I always say this, tubes are more important than the centrifugation device that you're going to utilize, okay? A lot of commercial debate, should I use this system, should I use that system, on and on and on. The reality is that, number one, the tubes are critical for the production of platelet-rich fibrin, okay? They're more important than the centrifuges. Centrifuges, there's two classifications. So there's the fixed angle centrifuges, and then there's the horizontal or the swing out bucket, and I'll show what they are and why the horizontal ones are better. But when it comes to tubes, a lot of people think because it's a red cap tube, it's the same as another red cap, etc. But reality is that there's a lot of different variability in simply the actual tubes, okay? Now, how do tubes work? Well, very simply, it's very similar to implant surfaces. If this right here is an implant surface, okay, I want this to be as hydrophilic as possible. And the reason why is that if I make a hydrophilic implant surface, then platelets are drawn to this hydrophilic, which means water-loving surface. The platelet will then bind to it a little bit faster. The platelet then degranulates and releases its growth factors a little bit faster and gets activated. And then I get faster osseointegration. So if you look at implant dentistry and you look at, the Nobel active surfaces or the SLA active or these companies that are changing the implant surfaces, several years ago, a lot of the times what they're trying to do is make it more water-loving, because then they can attract these cells to bind to it faster, and you start the whole biological process a bit faster as well. The same is true with tube surfaces, okay? If you make an actual PureF tube wall more hydrophilic, it's more water-loving, that little platelet will then bind faster, and when he binds there, that clot will form thereafter, and you'll get a bigger and better clot essentially based on that glass wall, okay? And glass is better at doing that. So when you see the red tubes, again, hydrophilic surface here, usually made out of glass. Other companies will make these silica-coated plastic ones. They don't work quite as effectively. But long story short, you're trying to make them hydrophilic. Now, when you want to make liquid PureF here, the opposite is true. Now, if I make a tube wall surface and it's very hydrophobic, then that little platelet that wants to bind to that surface, it's water propelling, it's hydrophobic. So water is not attracted to it. So that little platelet that's floating around in this liquid can no longer bind to that surface, and instead he stays in this liquid environment longer. As a result, it stays liquid longer. And then you can do things like drop the liquid PureF and do knee injections, facial injections. You can use it as a liquid device. So the tubes are very important, because if you're one of these people that you spin PureF and sometimes you get big membranes, little membranes, medium membranes. Sometimes you spin and there's no membrane at all, and you're using a red tube. It's not that you spun incorrectly or did something wrong. A lot of the times it has to do with the tube that you're using, okay? Because if that tube is more hydrophilic, then it will make, more standardized membranes that are better. The more hydrophilic I go, the better the membrane. Liquid, the more hydrophobic I make that tube, the longer it'll stay liquid for. Okay, so there's real advantages to understanding how these tubes here work.